Hi guys, welcome back. So today I have a fresh set of more logarithmic equations. Some of these bad boys are going to have one log term. Some of them may have more than one log term. So let's do this. So we are asked to solve each equation. And as always, we are expected to give exact solutions. Before we do our first or fourth problems, let's just go ahead and throw out a few friendly reminders. So if we have, say, a logarithm base b of x. So a few housekeeping rules. The base of the logarithm has to be a positive number. Okay, so the base of the logarithm has to be a positive number, but with the exception of 1. Okay, so it could be any positive number with the exception of 1. And then what is a logarithm? A logarithm is just an exponent. So this is going to equal some number that we'll just call it y. Okay, a logarithm is just some exponent. What are other housekeeping rules? Well, we know that the base of the logarithm has to be some positive number other than 1. And we also know that the argument has to be positive. I was having a moment, I forgot how to spell the word positive. Now, our base is some positive number. The log is just an exponent. So when we take this base and raise it to any power, whether it's a positive number or a negative number, some positive number raised to any exponent, that will always give you a positive result. Okay, so yeah, things to keep in mind. Now, coming back to problem A. So the question is, how are we going to solve this this logarithmic equation? The first thing I need to ask myself is this: how many log terms do we have? Is it 1 or more than 1? If we only have one log term, then our first goal is to get it out of log form. Let's go ahead and put it in exponential form. Now the question is, how are we going to handle it? You got two options. Option 1, you can either memorize log base b of x equals y, means b to the y equals x. To tell you the truth, I don't even know if I wrote this correctly. I should have reviewed my notes. Okay, so again, we can just be like, oh yeah, log base b of x equals y means b to the y equals x. Yeah, you could do that, but I said it before, memorize what you absolutely have to, but try to understand as much as I can. Okay, so with your permission, this is how I do it. So I'm like, okay, how do I get out of logarithmic form? How do I write this in exponential form? I'm going to remember the following. Base raised to some power equals argument. Base to some power equals argument. Okay, to go from logarithmic form to exponential form, base to some power equals argument. All right, let's ID what we can. The base of the logarithm is 5. Okay, base of a logarithm is 5. So we have base raised to some power will give us the argument. Now it's like, where is the power or that exponent? Well, you got to remember what the log is. Okay, a log is just an exponent. So if the log equals 3, then check it out, the exponent equals 3. So base to the exponent of 3 equals the argument. Argument, that's something I'm going to have in the back of my mind. Argument is just code for whatever you're taking the logarithm of. Okay, base to some power equals argument. Fantastic. So now we're going to focus our energy on solving this linear equation. So let's do this. So you could use a calculator or freehanded. It's a personal choice. 5 to the 3rd power, I believe it's 125. We bring down the rest of the problem. Take your time, do what you got to do. We have a degree 1 equation or linear equation, so let's old school it. Variables on one side, non-variables on the other. Work your magic to isolate the variable term. To get rid of the +2, inverse operation, or the opposite of addition is subtraction. So let's go ahead and subtract both sides by 2. When we do, that will give you 1, 2, 3. Equals 3x, cool, 123. To finish it off, to get rid of the times 3, work your magic and divide both sides by 3. Go ahead, freehand it or punch it in. I don't have time to freehand it, so with the use of a calculator, that will give us 41 equals x. Okay, thanks to you guys, I know I didn't make an algebra mistake, but this is the thing. When it comes to solving logarithmic equations, we gotta check our answers. Well, I lie. Okay, let me rephrase it. When it comes to solving logarithmic equations, we gotta make sure that the argument is positive. So I'm not really gonna check my answer. I just want to make sure all my arguments gonna be positive. So I'm gonna write down what I call the argument check. So again, I'm not really checking my answers. I just want to know, like, is my answer like acceptable, you know? So we're gonna write down the argument. The argument in this case is 3x plus 2. And then we are hoping that when we substitute our answer for the variable, our argument will remain positive. So we have 3 times 41 plus 2. Product of 3 and 41 is 123. And when we add 2 to it, that will give us 125. So I'm very thankful that our argument is positive. Okay, so I'm going to go ahead box it. Okay, now I don't really, because we didn't really check it, we don't have the certainty of our answer is correct. I just want to make sure, like, I wanted to make sure that it doesn't make the argument negative. But for those of you that are overachievers, let's go ahead, check it, all right? So I know you understood what I was trying to say. So the equation reads log base 5 of 3x plus 2 equals 3. Okay, so we're gonna do the actual checking because some of us are not just content with, like, yeah, I know it's acceptable. I need to make sure it is the answer. Okay, so the solution, we have x equals 41. When we plug it in, we want to make sure that the left side equals the right side. So let's do this. So we have log base 5 of 3 times our answer plus 2 equals 3. I'm not sure if you can read this, sorry. Product of 3 and 41 is 123. We're going to take the logarithm base 5 of it. Sum of 123 and 2 is 125. We're going to take log base 5 of it. And the question is, does the left side equal the right side? So I'm like, log base 5 of 125, what does that simplify to? You could put it in your calculator, but I'm going to try to freehand it. So I remember that a log is just an exponent. So I'm like, base to what power is going to give us the argument of 125? So I'm like, 5 to what power is 125? I'm like, oh yeah, 5 to the third power is 125. Okay, so you could punch it in if you're having a moment. The left side equals 3, the right side equals 3. Last time I checked, 3 does equal itself, so it checked out. So now we can box our answer with confidence. Me checking the answer by hand does take a while, so I normally, like, just trust my algebra. And I don't really check it. I'm just going to do the argument check, meaning verify that all the arguments are going to be positive. Okay, so I have 4 problems planned for you. That's problem A. Let's go ahead and knock out problem B. Okay, problem B, we have log base 3 of x plus 1 raised to the 5th power equals 3. Okay, so this problem is similar to problem A in the sense that we only have one log. So if we have only one log, then I guess our primary goal is to get it out of the log or put it into exponential form. But this is the thing, this argument right here, x plus 1 raised to the 5th power, it's a little bit out of my comfort zone. So with your permission, we're going to go ahead apply the power rule for logarithm. So let's go ahead and remind ourselves. So the power rule for logarithm says this. Okay, so the variables, you don't have to remember them in this order. It's just more of an understanding. Okay, so the power rule for logarithm says this: if your argument is being raised to some power, wouldn't it be nice if we could tone down the argument? Okay, so we're going to take that exponent and then multiply it by the leftover logarithm, which is log base b of x. So I would rather take the logarithm of x versus the logarithm of x to the r. Okay, so let's go ahead and do that for our problem. Okay, let's tone down the argument by using the power rule for logs. Okay, so let's bring that exponent down. and that will leave us with 5 times leftover logarithm, which is log base 3 of x plus 1. And then we bring down the rest of the problem equals 3. There are different ways to approach this problem. Sometimes I see it in one way, tomorrow I may see it a different way. It doesn't really matter, okay? Do what you got to do. At this point, I'm going to go ahead and work my magic to get rid of the times 5, okay? So to get rid of the times 5, let's go ahead and divide both sides by 5. And when we do, that will give us log base 3 of x plus 1 is equal to 3/5, okay? So now the question is, how are we going to handle it? So the question that I'm going to ask myself is this: how many logs do I have? Is it just one log or more than one log? Since we only have one log, then our primary goal is to get it out of the log, put it in exponential form. So remember, base to some power equals the argument. The base is 3. Base to some power equals the argument. So then I'm like, where's the power? Where's the exponent? Now, just remember what the log is. A log is just an exponent. So if the log equals 3/5, then the exponent equals 3/5. So coming back, we have base to some power equals the argument. So argument in this case is x plus 1. Okay, the numbers look funny, but it is what it is. Go ahead and work your magic to isolate the variable term. To get rid of the addition by 1, let's go ahead and subtract 1 from both sides, and that will leave us with 3 raised to the 3/5 less 1 is equal to x. Cool. So I know that we didn't make an algebra mistake, but I want to make sure that our answer doesn't make the argument negative. So let's go ahead and do the argument check. So argument check, verify that the argument is positive. So the argument in this case is x plus 1 raised to the 5th power. X plus 1 raised to the 5th power, and our proposed solution is x equals 3 to the 3/5 minus 1. Let's do what we got to do. Okay, so we have x in this case is 3 raised to the 3/5 minus 1. What's going on with that x? We're adding 1 to it, and after we do that, we're going to raise it to the 5th power. Again, argument check. Make sure that your argument is positive. Negative 1 plus itself, negative 1 plus 1 will give us 0, and that will leave us with 3 raised to the 3/5, and that is being raised to the 5th power. So at this point, let's go ahead and apply the power rule for exponents. So raising powers, you're going to keep the base and then multiply the exponent. So that will leave us with 3 raised to the 3/5 times 5. We clean it up. Product of 3/5 and 5 will give us 3. 3 to the 3rd power is 27. So again, we're not really checking it, okay? We're doing the argument check, meaning we want to make sure that the argument is positive. Last time I checked, 27 is positive, so we're good. For those of you that are overachievers, then you check it, and make sure that the left side equals the right side. Okay, guys, that's our second problem. Let me go ahead and hunt down the final two. Okay, guys, so let's go ahead and do our third and almost final problem. So when it comes to solving logarithmic equations, remember the first thing we want to ask ourselves is this: how many logs do we have? Is it one log or more than one log? As you can see, we have more than one log. When you have more than one logarithm, your primary goal is to fix it so you have no more than one log on each side. So in this case, we have more than one log on the left side, so let's fix it so we have a single logarithm. So we are going to backtrack it to a single logarithm. How? I forget. So when I forget, I get mad. But I get really mad. So I'm going to say I'm so mad for forgetting. But it's okay, because my frustration is going to remind me how am I going to handle it. If I am adding two logarithms, then when we backtrack to a single logarithm, we're going to multiply the arguments. If we are subtracting two if we are subtracting two logarithms, then we would divide the arguments. In this case, since we're adding the arguments, when we backtrack to a single logarithm, we're going to go ahead and multiply the arguments. So let's go ahead, write down logarithm. You keep the base. What are we going to do to the arguments? We're going to multiply them. So it'll be first argument times second argument. And then we bring down the rest of the problem. There's nothing else on the left, equals 2. Okay, now at this point we only have one logarithm. Okay, so since we only have one logarithm, we are going to write this in exponential form. So to do that, it's base raised to some power equals the argument. The base is 4. The log, a log is just an exponent. So if the log equals 2, then the power is 2. So we have base to some power equals the argument. Base to some power equals argument. Let's take our time. Oh, that's not really good. Let me play with the lighting. Oh, that's even worse. Let me fix this. Okay, I think that looks a little bit better. So let's go ahead, clean this, and then make a strategy of how to solve it. The square of 4 is 16. Let's take our time to simplify the right side. Product of 2x and x is 2x squared. Product of 2x and 2 will give us 4x. Fantastic. So now at this point we have a degree 2 equation or a quadratic equation. You can solve this however you like. You can solve by factoring, completing the square, quadratic formula, whatever works for you. For me, I'm a big fan of factoring, so I'm just going to assume it's factorable until I realize it's not. Okay, so when it comes to factoring, our first step is to set the equation equal to 0. So let's go ahead, subtract 16 from both sides. When we do, that will leave us with 0 is equal to 2x squared plus 4x minus 16. Fantastic. Prerequisite step when it comes to factoring is to watch out for common factors. So I believe that all three terms have a common factor of 2. So let's go ahead, factor it from the expression. When we factor out a 2, that will leave us with x squared plus 2x minus 8. Cool. Let's take our time and factor the resulting trinomial. Since the leading coefficient is 1, then we can just go straight to throwing down parentheses. We focus on forming the product of the first terms. The product of the first term should give you x squared. So to do that, we're going to use variable times itself. To complete the binomial factors, we want factors of c that add up to b. Factors of -8 that add up to 2. I believe there's a 4 and 2 in the picture. Product is negative, so one number has to be positive, the other one has to be negative, and in this case the larger factor will have to be positive. So let's go ahead and check it. Product is -8, sum is +2, so we're good. Let's bring down the rest of the problem. Now that we have factored, let's go ahead, apply the zero factor property and set each factor equal to 0. So either the first factor equals 0, but that's a lie because 2 doesn't equal 0. Or the second factor equals 0. Or the third factor equals 0. Okay, if the first factor equals 0, after we subtract 4 from both sides, that's going to lead to a solution of -4. If the next factor equals 0, that's going to lead to a solution of x equals 2. Now, I know we nailed the algebra, but remember, when we have logs, we got to make sure that the arguments stay positive. I want to keep my answers here, so let me go ahead, write down the equation again. So we have log base 4 of x plus 2 plus log base 4 of 2x equals 2. Okay, so we need to make sure that the arguments remain positive when we check it. When x equals -4, -4 plus 2 is -2, I think. So that's not going to be positive, so we can't use it. But to remind myself, let me just go ahead and write out my thought process. Argument check. Verify that the argument is positive. The first argument is x plus 2, and then we'll check it against the other argument, which is 2x. So we got a x plus 2, and then our first solution is -4, and we need to confirm that the argument is positive. We got -4 plus 2. That sum is -2, and -2 is not positive. Now, when it comes to logarithms, the arguments always have to be positive. In this case, it's not, so we cannot use it. It's an extraneous solution. Should we check it against the other argument? There's no need to. If it doesn't work out for one, then that's it. We can't use it at all. Let's check the other one. When x equals 2, we have two arguments involving a variable, so we gotta check both. The first argument is x plus 2. And we want to confirm that our argument stays positive. Sum of 2 in itself is 4. It is positive, so we can use it. Okay, we're not going to eliminate it. So we're not really checking it. If you really want to check it, then you plug it in, make sure that the left side equals the right side. I just want to know, like, can I use it? Does it fly? Our next argument the next argument involving a variable is 2x. Our solution is 2, and we want to make sure that the argument is positive, and in this case it is. So we can use it. We had two possible answers, but we couldn't use one. We have something to go by, so in this case the solution is just 2. Okay, that is our third problem. Let me find our fourth and final problem, and then we're out. Okay guys, so let's go ahead and do our fourth and final problem so we can be out. Okay, so when it comes to solving logarithmic equations, the first question that I'm going to ask myself is this: how many logs do I have? One log or more than one log? As you can see, we have more than one log. When you have more than one log, your primary goal is to fix it so you have no more than one log on each side. We have a single log on the right, so we're cool. Our issue is with the difference of logs on the left. So the question is, how am I going to backtrack this so we have a single logarithm? And I forget, and when I forget, I get mad. I get so mad that I'm so mad at myself. So then I'm going to ask myself this question: what am I doing to the logarithms? Am I adding them? Am I subtracting them? And in this case, we are subtracting them. So check it out. If we're subtracting the logarithms, then when we backtrack to a single logarithm, we're going to go ahead divide the argument. So it'll be log of the first argument divided by the second argument. So we have log and then quotient of the arguments. So be first argument divided by the second argument equals log of 2. So now we have satisfied our primary goal. When you have more than one logarithm, your first goal is to fix it so you have no more than one log on each side. At this point, what are we going to do thereafter? We're going to go ahead and apply the property of logarithmic equations. So you don't have to remember it in terms of variables. It's more of an understanding. Okay, so the property of logarithmic equations says this: if you got two logs set equal to each other, and if the bases are equal, then there's no way around it, then the arguments have to be equal. Okay, now what is the base of each logarithm in our problem? The base of the logarithm is not highlighted, which means that we have the common logarithm, or a logarithm of base 10. So we have 1 log equals 1 log. So then I'm like, okay, what is it that is the same? So in this case, the bases are the same. So let's apply the property of logarithmic equations, the one that reads that if the bases are equal, then there's no way around it. The arguments have to be equal. So let's set them equal to each other. So we have left argument equals right argument. So we went from a logarithmic equation to a rational equation. When it comes to solving rational equations, remember, we have to watch out for restrictions on the variable. So we want to know what makes the denominator equal to 0. When we take that x minus 3 and set that equal to 0, that's going to lead to a solution of x equals 3. So we want to tell the world x cannot equal 3. So let me highlight that. Now at this point, we're going to work our magic to try to wipe out the fractions. There is only one denominator, so guess what? That one denominator is our least common denominator. Let's go ahead and show the world what we're left with when we multiply both sides by the common denominator let's go ahead and show the world what we are left with when we multiply both sides by the common denominator. On the left side, the quotient of x minus 3 in itself will give us 1, or we say that cancel out, and that will leave us with 4x equals whatever we get after we distribute the 2. Product of 2 and x is 2x. Product of 2 and negative 3, where am I, is a negative 6. Work your magic, fix it so you have variable terms on one side, constants on the other. If I can read your mind, let's go ahead, subtract 2x from both sides. And if you didn't do that, it's fine. I just couldn't read your mind. After we subtract 2x from both sides, that will leave us with 2x equals negative 6. And for the grand finale, to get rid of the times 2, let's go ahead, divide both sides by 2. And that will leave us with x equals negative 3. I'm pretty confident with our solution. I don't think we made an algebra mistake. But again, because we have logarithmic equations, we gotta make sure that our arguments are positive. So let's do the argument check. Meaning, let's make sure that all our arguments are positive. Okay, the first argument involving the variable is a 4x. And then we want to know if the argument stays positive. So we have 4 times our solution of negative 3. And that will give us negative 12. Negative 12, last time I checked, is not positive. Now, what has to hold true for logarithms? The arguments have to stay positive. In this case, it's not, so we cannot use it. Now, we have one possible answer to go by. We can't use it. Since we have nothing else to go by, then there is no solution. Okay guys, so I had promised you 4 problems. That was our 4th and final problem, so we're out. Thank you.